It's a pleasure to be here tonight and to talk about two of my favourite topics, one of them being astrophysics and the other one being alcohol. So tonight I'm going to tell you a little bit about where all this interstellar alcohol comes from in space. And the stars themselves are not in the vacuum of space. Between them there is gas clouds, and there's lots of gas out there, and most of it is made out of hydrogen. There's a little bit of helium in there, but then there's a small proportion that's organic molecules and things like alcohol. And at the end of this talk, hopefully we all understand a little bit more about where this interstellar alcohol comes from. Now, alcohol and astrophysics can probably be a bit bad for you if you have a bit too much of either. And the effects can be very pronounced. It can cause extreme belligerence, a lack of respect for authority, and that's just the guy in the top right. But it also can change your perception of the world and your perception of yourself. It can bend space, it can bend time. And as you can see from this selfie that I took at the weekend, after a ton of Guinness, it bent my perception of my own world as well. But I'm not here to talk about me. I'm going to talk a little bit about a recent result that came out from the world of astrophysics. And what they found was that even in one patch of the sky where there was a gas cloud, they found that there were 400 trillion pints of beer of alcohol just in those gas clouds. So I looked it up, and that's a yota pint. 400 yota pints, 10 to the 24 pints. That's a lot of pints. So the question is, where does all this alcohol come from? How do you make that alcohol? Well, just to remind you what alcohol is, if you don't need reminding at this point, some of it's good for you. Some of it isn't very good for you, but it's all basically the same stuff. It has an OH group on it. It has oxygen and hydrogen in a little group together called the hydroxyl ion, and that's what makes it an alcohol. The simplest form that there is methanol. And methanol is something that really is not good to drink. That's the stuff that makes you go blind and kills you, in very small portions. Ethanol, on the other hand, also can make you go blind and kill you, but you've got to drink an awful lot of it. And it's made in pretty much a similar way. Here on Earth we make it one way, and out in space there's another way that we can make it. Here on Earth we've been doing it pretty much the way these guys have been doing it for the past few thousand years. There's not much to it, really. All you got to do is you got to get some water, you got to get some yeast, you got to get some grain or barley, you got to ferment it, and then you got to distill it. And once you distill it, you can separate out all of the alcohol and make this lovely ethanol that we then leave impurities in that gives it its nice taste. So these guys make it one way. But for us cosmic chefs out there who are trying to cook up alcohol, we need some basic ingredients. And the basic ingredients for the guys from the Appalachians, or from us guys out in astrophysical space, the ingredients are pretty much the same. There's three simple atoms in there. There's either hydrogen, that stuff comes from the Big Bang, or carbon, which comes from stars, or oxygen, which comes from stars. And all of us in this room, all the stuff around us, is made out of this hydrogen and this carbon and this oxygen. I think that's absolutely mind-boggling. I actually almost don't believe it. You've got to leave your human side away from your scientific side sometimes, and sometimes you just don't believe it. All the hydrogen that's in that alcohol on your table, and in all of you, came from the Big Bang. It hasn't been created since that time. That's where it all came from. That's all the hydrogen in the universe. 75% of the entire universe is hydrogen gas, or hydrogen. The carbon and the oxygen are very hard to make, but you've got to stick hydrogen and helium inside a star and cook it up for a few billion years. And then it gets even more complicated, because you've got to get it out of there to make alcohol with it. So you've got to get the star to blow up. And once the star blows up, then it can get all the carbon and the oxygen out into space, and you can make alcohol. And then there's another step to make. You've got to make your hooch in space. So let's start at the beginning. And Shane went back to 1944, which he called a long time ago. We're going to start 13.798 billion years ago. And this is when the Big Bang happened. And this is not what we believe. This is what the data points us as. This is the best data that we have. It points that there was a Big Bang. We're not making it up. It's just what we think happened based on the data. And on the far right-hand side, you'll see where the Big Bang started. And this is where it gets unbelievable. This is where we had nothing. There was nothing in space. There was no time. There was no space. There was no matter. There was no people. There was nothing. And I can't deal with this. You've got nothing, and then Heisenberg comes along and said, don't worry about it. You go delta H, delta T is sort of like H bar. And that means that if you wait long enough, you can get small fluctuations in energy, or if you don't wait long enough, you can get big fluctuations in energy. And that's about it. And what happened was there was fluctuations in nothing. I'm not religious, but I think you need to pray to believe this kind of thing. Anyway, it started, some of these bubbles of nothingness began to expand. And as they expanded with all of their energy in them, the energy turns into mass. Again, this is a bit wacky. The energy can turn into mass, but E equals mc squared allows you to turn energy into mass. And from the nothingness came energy, and the energy turned into protons. And we ended up with some protons, and protons with electrons around them are hydrogen atoms. They were the very first pieces of atoms that were left around in the universe. They're the building blocks of everything around us, including the stuff that you guys are looking up to consuming right now. So that's the first atom that we have in our magic formula to create ethanol. How do we make the carbon and the oxygen? Well, that's where the stars come in. Once all this hydrogen was left right across the universe, some of it was spinning a little bit. Some of it was moving around as gravity was pulling it together. And the gas clouds began to collapse. Big gas clouds collapsed and formed big stars. Small gas clouds collapsed to form small stars. And these were the cosmic cookers. And inside the gas cloud, inside the stars, there was so much pressure and temperature that it pushed hydrogen together to form helium. And then from helium, we started burning the helium and pushing helium together to form carbon. And then from carbon to oxygen, and the whole way up until you get to iron. So inside stars, we're making all the stuff that we're all made of. Every single thing inside you is made up from these early stars. But once you reach iron, the star just can't support gravity anymore, and it blows up. And it throws out all of that stuff out into space in what's called a supernova. And if you've got a big star, like the supergiant, the red supergiant down the bottom there, it blows up to leave a supernova. And a supernova is an enormous explosion. And what that explosion there is showing you is just bits and pieces of atoms going flying out into space. So now we've had our cosmic cooker that's created our carbon and oxygen, and now we've got to put them all together to make alcohol. And so this is where we have to wait a long time. The hydrogen was made in about 1 second. These ones were all made in about 1 million years. So that's 1 million years out of 3.7 billion years. So this was actually all very quick in terms of the making up of our ingredients that we need to make alcohol. So that's where cold space causes a problem. If you want to make atoms turn into molecules, you need it to be hot. And space is not hot. It's about minus 200 degrees Celsius in a gas cloud. So it's very, very difficult to make atoms stick together in space because it's so cold out there. And that's where the wonderful, wacky world of quantum mechanics comes in and makes improbable things happen. And you're going to hear more about that in a little while. But also, space is not just cold, it's got dust in it. Those big fingers here, they call these the fingers of creation, for some reason. And in those fingers of creation, you have lots and lots of dust. So dust, by dust I mean sand grains. Tiny little sand grains, which are made out of silicon and oxygen. And the silicon and oxygen came from the centre of stars as well. But on those dust particles, then oxygen can land, carbon can land, and oxygen can land, and they can stick to the surfaces. So the dust becomes a small little organic chemistry lab. And then the stars shine on this organic chemistry lab, and they make the atoms move closer and closer together. But there isn't enough energy for this to happen. And the old guys and girls from the 1600s and 1700s and 1800s in chemistry would say, this can never happen. It's too cold. You can't have chemical reactions if it's too cold. But this fellow Dubliner over here, Erwin Schrödinger, in fact, he had an Irish passport, so he was an Irish citizen. So he was actually another Nobel Prize winner from Ireland, from the O'Schrödinger clan. And his mother was Irish as well, so there is really genetic Irish in there. So let's remember Erwin Schrödinger for 15 years in Dublin. But classical chemistry and classical physics would have said there's no way these things can combine, it's too cold. Schrödinger said, I've got a way of getting around this. These atoms and molecules and so on all have what are called wave functions. Okay, more science that I don't believe, but it's the truth. But what happens is they have wave functions, and that means they don't behave like little point objects. They actually behave like waves. And the waves have tails that search out into space and hook each other together and form chemical bonds. And that kind of searching out through space and pulling together is a thing called tunneling. They're not meant to come together classically, but for some reason, because they are quantum particles that behave like a wave, they overlap with each other and they can form bonds. And that process is called quantum tunneling. So I spent 2 hours in PowerPoint this morning doing everything I could to avoid correcting exam papers. Undergraduates. They were fascinating strips, by the way. And this is to explain how quantum tunneling happens. Well, you could either... So the two atoms on the left and right-hand side, they want to combine together, but the energy to combine together is just too much. They've got to go up too high. They've got to get too much energy to bang into each other. So it's never going to happen. So you can take one of two approaches. First of all, you can take the Father Jack approach. And you can say, feck off quantum barrier, which probably won't work. The alternative is to look at Erwin Schrödinger and see what he predicted. And what Erwin Schrödinger said, feck off quantum barrier, we're going to create a quantum tunnel. And so instead of having to go up over the mountain, what you've got to do is you take the easy approach and you tunnel through the barrier, and then the molecules and the atoms can combine together. So it was quantum tunneling that allows these atoms to interact with each other and form molecules. So that's the way that we're able to get the hydrogen and the carbon and the oxygen all together to form our interstellar alcohol on our dust grains. So the story goes from the very start of space-time, which is 13.7 billion years ago, where we formed the hydrogen. Then within a second, we had all the hydrogen that we needed. Then we had our gas clouds. Our gas clouds then collapsed. This is all undergraduate physics, by the way. This isn't even that hard physics. This is just undergraduate physics. And then what happens is the gas clouds collapse, they form the stars, and then we cook up all of the elements, and then the stars explode, and then we have our dust grains. And our dust grains become the saucepans in space where we're cooking up the carbon and the oxygen and the hydrogen to make our interstellar alcohol. So for me, this has been a great discovery that we've been able to find complex molecules in space. And when we take big radio telescopes and look out into space, we're now not only seeing alcohol out there, we're seeing amino acids can be seen out there. We can see carbon monoxide out there. We can see carbon dioxide out there. We can see NH3, ammonia molecules out there. All the building blocks of life are out in interstellar space. So for me, in the next 20 years, as we go on to find more planets, more stars, more exoplanets. When I was a kid, there was only 9 planets. Then the Americans kicked out one, and we went down to 8. And then, now we're up to over 1,000 planets way outside in the solar system. In our future, maybe we're going to be looking for more complicated molecules than this and finding biomarkers. Imagine if we see a press release for a paper that says, we have seen the signature of DNA on another star system. I think that could be pretty shocking science. So thank you very much for your time.